last week we discussed amplifier classes. We discussed vacuum tube basics. That's kind of the two parts of the puzzle. Now I want to put them all together, and I want to talk about vacuum tube amplifiers. How do they work? Now, I'm not going to get into the details of, biasing a tube or anything like that. That is very similar to how you would bias a transistor amplifier. I say bias in terms of design. I'll talk a little bit about bias in terms of changing tubes later. But as far as how you set up a simple inverting gain stage, it's very similar. And we'll look at that a little bit. But I'm not going to go into depth on it. The main idea is the same as with transistors. You want to put it in a linear region, right? Unless you want to create distortion, in which case nobody's come up with a good set of rules. The important thing to know about the distortion, we'll see this more with the effects lecture starting this week, is that remember we said that the even order harmonics are octaves, and so they're kind of more pleasing. The interesting thing to look at from a Fourier analysis point of view is that you can only get even harmonics if you have asymmetric distortions. Okay? If you look at if you take a series and take any waveform and clip it symmetrically, just do the same thing the top and the bottom, you'll get something that is say you got your sinusoid, right? That is symmetric around the origin, that this part flips above and down like this. So if you do something symmetrically, say just clip the top, there's nothing you can do about that that can introduce even harmonics. Because only odd harmonics have that same symmetry on both sides. So you need to do something asymmetric to introduce even harmonics. Okay? And if you look it up in your circuits book, you'll see there are certain rules of symmetry and the Fourier components that you get from those rules, and that's one of the rules. Okay, so we'll get into the vacuum tube amplifier now. Big thing to talk about, power supplies. We've got nothing without power. So I'm going to break it up into two parts. Often you can see this, sometimes they don't even include it on the schematics, sometimes it's drawn off in a little corner. We'll go through a couple example schematics. But basically there are two big levels of the power supply. The first is the heater power supply, right? Vacuum tubes only work if they're heated. Well, for the most part, they only work if they're heated. There are special cases. Power supply, now normally you'll see just about everything will be AC, okay? Vacuum tube heater is like a light bulb, right? Light bulb works on AC or DC. So you will occasionally see DC, and the benefit of that is reduced noise, right? If your vacuum tube is an amplifier element and you're pumping in extra AC just to heat it, that's extra noise. So you'd like to do that DC, and a lot of the better amps, the boutique amps, do rectify that into DC. The problem is, it's more expensive. You need more parts to rectify it and create the DC. So usually you'll see AC. And again, whether it's indirectly heated or directly heated affects how much noise is introduced anyway. Yes?
The DC rectified current, I guess. That's not why, it doesn't have anything to do with like rectifier.
We'll get to that. That's the high voltage that we're talking about. Yeah. No, so in this case, no, there usually is no rectifier in your heater circuit. 6.3 volts AC is the most common heater voltage. And the reason why is the most common tubes are either 6 series tubes or 12 series tubes. And with the American designation of tubes, like I mentioned last week, the first number tells you the heater voltage. So the 6V6 and the 6L6 use 6 volt heaters. 12AX7 nominally is 12 volts, but it really is 2 heaters with 3 terminals. So you can, these are the heaters, and you have access to these 3 points. You can run it in series and get 12 volts, or you can run it in parallel and use it as 6 volts.
When you run DC, do you run the same voltage, like 6 volts, say, or?
Yeah, I think so, because 6.3 volts is the RMS voltage.
It's the RMS voltage.
Yeah. Yeah. So.
Cool.
Okay, now so that's the heater, that's what gets them hot. But that's not going to move the electrons across the gap, right? To move the electrons across the gap, we need a high voltage. So we look at our AC power plug, that's 110 volts. So we know we need anywhere from about that up to 500, 400, 500, 600 volts, somewhere in there, depending on the amp. So we need a step-up transformer. Okay? So typically, your power supply, it comes in, and what you've got is something that looks, well, we'll see it when we get to the schematic, but it looks kind of like a really huge transformer where we've got the input, the high voltage, the heater, and then occasionally you have other windings if you're doing like, if you need other voltages out. Typically we just step down the high voltage to get the other voltages, but some amps may have a separate winding. Okay, now your question about the rectifier, Paul, is the DC, you can get it either from a solid state rectifier or a tube rectifier. And the best example of or probably one of the few examples of doing it either way is the Mesa-Boogie dual rectifier. And it's called the dual rectifier because it has 2 rectifiers and you can pick which one you use. You can either pick a tube rectifier or a solid state one. And the reason why is the tube diode has much, much greater voltage drop. And in fact, some of the handouts I handed out, they show some modeling schematics you can use to simulate a tube rectifier with a solid state rectifier. It's basically a solid state rectifier plus a resistance, and I think plus a little inductance. Don't quote me on the inductance. But the main thing is that you've got a lot of drop over, and the drop changes as you play, and that gives the effect that's called sag. And sag means, quite simply, you assume you've got power supply rails. And typically with any engineering design, you just assume power supply rails with a power supply rail. And if you've got a really good power supply and you're not drawing too much, that's a safe assumption. Problem is with a lot of tube amps, it's not. You don't have a linear rectifier or anything to guarantee voltages. So your voltages in part depend on your current draw. So if you've got something that's class AB and your current draw is varying a little bit, you're going to draw more or less from your power supply. If you've got a tube diode that has a lot of internal resistance, that's going to create a larger and greater, or a smaller and larger step size. It's going to sag. It's going to decrease your power supply range. So that's a real problem, or a real benefit, depending on how you look at it. A lot of people like sag, and the interesting thing about it too is it's dynamic. Because when you first hit something, it comes in after and it gets a sustain, and it's a very interesting interdependency of how the power supply affects the sound of the amplifier. And like I said, the best example is the dual rectifier. See, it's the same amplifier except 2 different rectifiers. You can just flip, you can't flip the switch while you're playing, but you can flip the switch and play it 2 different ways, and it can have a very different sound just based on how you get the DC voltage. Yeah, that was actually something that came up when I first taught the class. Somebody asked me about that. What is the dual rectifier? I don't know. Look at it.
I have a triple rectifier that does the same thing, though. I don't know why they call it that.
I forget. I think what happened was they came out with, I think the dual came first, and then they came out the single as a cheaper version,
Right.
and then I think they came out the triple as the deluxe version.
Okay.
And I don't remember what the third variation is. Do you remember?
No, I mean, the only difference that I would notice is they're 50 volts, 100 volts, and 150 volts for single.
Oh,
volts
okay.
and triple. I know that the triple I have is 150 volts, I think, or 100 watts. I'm sorry, 150 volts.
Oh, okay. It could be that that it does some variation on the third one. I forget what it is. Obviously, 2 of them are solid and 1 of them's tube, or 2 of them are tube and 1's solid. But I forget what that third setting is. Interesting to find out. You get the find out.
If you want just the rear panel from it, there is actually one switch on it that I really couldn't tell you electrically what it does. It's different.